Hello, my name is Ben and today I'm going to be sharing with you my Internet of Things project called Smart Racking. So Smart Racking is a device you would find in a supermarket or a warehouse, and what it would do is it would measure the amount of product you would have on the shelf at any given time. So as you can see the device, we have 4 sets of scales, each one with 2 load cells. Each load cell can hold up to 50 kilograms, so in total each scale can hold up to 100 kilograms of product. You can't quite see it clearly, but at the back here we have an OLED display displaying the temperature in degrees Celsius, and at the other side we have the temperature and humidity sensor. So if we turn this device around, we can clearly see the chosen microcontroller is the Pi Zero. This is a cost-effective device which costs about £9. It's already preloaded with the program and it's set to run and execute on the boot, so we don't have any need for the keyboard and mouse or the HDMI display. This side we have our 2 OLED displays, and they are connected to the I2C multiplexer. The reason for this is because both OLED displays share the same address, so to address them individually we're using this device. On the opposite side you can see the temperature and humidity sensors. These are the DHT22 sensors. In the middle here, these green circuit boards are the HX711 sensors, and these are the weight sensors. And what they are doing is converting the analog data from the load cells and converting it into digital data so the Pi can read it. So if we turn this back round, what we'll do is we'll load up some of our test products. So these are just cans of drink. So we've got Coca-Cola, Dr. Pepper, Fanta, and a bit of a weird one, but Appetizer. So what we're going to do next is we're going to have a look at what happens once I've just put these products on the set of scales. The device updates every 5 minutes with the product count, the temperature, humidity, and the device ID. The Pi Zero acts as the client and it sends all of this data over to the server on my computer, and it does this using Python's socket programming. From the server, the data is then sent to Azure's IoT Hub through the MQTT protocol. From there, Azure Functions takes the data from the IoT Hub and formats it and then sends it to Azure's cloud storage. From there, I have programmed a React.js app, and it then retrieves all of this data from the cloud storage and displays it in a graph format as well as a table format showing the live data. We can see that device 2 has 4 products, so this is the Dr. Pepper. We can see device 1 has 3 products, which is the Coca-Cola. We can see device 3 has 1 product, which is the Appetizer, and we can see device 4 has 2 products, which is the Fanta. So when the data is sent from the server to Azure IoT Hub, it is sending the device ID along with the date time, the temperature, the humidity, and the product count. You can't really see it, but we've got 4 Dr. Peppers, 3 Coca-Colas, 1 Appetizer, and 2 Fanta. So what I'm going to do is I'm going to take one of the Coca-Colas off, one of the Dr. Peppers off, and one of the Fantas off. So now as you can see, device 2, the Dr. Peppers now has 3 items on it. We can see device 1, the Coca-Colas now has 2. Device 3, the Appetizer, still stays at 1. and device 4, the Fantas, now has dropped to 1. So as you can see on the website, we've got all 4 devices. So we've got the Dr Pepper, the Cola, the Appletiser and the Fanta. So as you can see, the quantity is updated. So we've got 3 Dr Pepper, we've got 2 Coca-Cola, we've got 1 Appetiser and 1 Fanta. So it's also showing the humidity at 42. That's for all of them, and then 21.6 degrees Celsius for the temperature. And obviously it's given the time, the exact time at which the readings were taken, as well as the date. If we go to our next page, Analytics, you can see 4 graphs. So we've got the stock time series graph. So what this is doing, this is showing the quantity for all stock altogether, so for all 4 product types. So as you can see, obviously each time we've got 4 being given, so obviously it's shot up from 11.25, it's gone to 4, 3, 2 and 1. The next one is the product time series graph. This one shows you just a bit more, so it's each product individually. So we've got product 4, which is the Fanta. So if we follow product 4 on the red line, so obviously there's 0, and then once I've added them on, we've gone to 2. We've dropped back down to 0, and we've gone back up to 2, down to 1. Same with product number 2, that is the Dr Pepper. So we started out at 4, well, we started out at 0, I've added the cans on, it's gone to 4, and as we've gone on over time, it's dropped to 3, back up to 4, and then back down to 3. So you can sort of see the variation throughout the day for the product quantity levels. So this could be used to help improve product management, the logistics, so product ordering, and it could give you an idea of how much product you would predict to sell in a day. The next 2 graphs focus on the temperature and humidity over time. So this one shows it quite well. So it showed at 10:55 the temperature is 20.4 degrees Celsius, and it's slowly gone up gradually, and it's gone up to 21.6 degrees Celsius. And then we've sort of had a little dip, and it's gone back up to 21.6 degrees Celsius. The next graph shows the exact same thing, so it's showing the humidity over time, so it's showing them for each device. So we've got device 4 being at 46, dropping down to 43.3, then to 42.8, back up to 44.8, and then back down. So there's quite, it changes quite a bit. So here you can see 4 different graphs, 4 different ways you can sort of analyse this data. So there you have it, that's my first prototype. So what I'm going to do now is I'm going to answer a few of your questions. So you could use any product you'd like, you don't have to use Fanta or Coca-Cola, it could be anything, as long as it's within the weight limit. So to change the product, you would have to change the weight to update the weight of the product. So in the future, if I was to develop this further, I would have another database with the products and their respective weights, along with the device ID. So what the system would do is, it would automatically update the device with the product's weight that you were looking for. The I2C multiplexer is a device which acts as the gatekeeper. So what it does is it allows devices with the same fixed address to have its own unique address. So with the case of the OLED displays, both of them share the exact same address. So to display 2 different temperatures, we needed a way to separate these addresses, and that's what we use the I2C multiplexer for. So the total cost of the project was around £50. This excludes the mount. This includes the Pi Zero, the temperature humidity sensors, the OLED displays, the weight sensors, the load cells, the LEDs and the resistors. So what I would do to reduce the cost even further is I would just use the temperature sensor. So this could reduce the project cost by £10 down to £40.